Alright, hello grade 6 and welcome to your first math lesson. Alright, as you can see from the slide, or the first slide, all it's going to be is a review of mixed and improper fractions. Alright, that's all we're doing in this first couple of days. The tests have marked the last ones that you did. If you were not here on that date, they will be emailed to you separately. It won't be for marks, but you'll have to work on them. Alright, and so what we're going to look at is we're going to review relating improper fractions to mixed numbers and mixed numbers to improper fractions. That's really all we're trying to do, right? Is how do they relate? Okay? This first slide, once I get my colors going, alright, all it's doing is it's showing us again that there's different ways to represent an image. So remember, we can represent them as a mixed number or an improper fraction. A mixed number is when you count the number of wholes and then the proper fraction left. So in this first image, you'd have 1, 2, 3 completed pizzas, right? With 1, 2, 3, 4 slices remaining out of a potential of 8 to make a whole. So you would have 3 and 4 eighths, right? As an improper fraction, right, you would count the total number of pieces that you have, right, all of them, and then you put that over, right, how many pieces make up a whole. So let's start with that one. Let's start with the denominator. That's the bottom number. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 slices make up an entire pizza. Alright, then we have to count how many slices do we actually have available. So we have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Alright, so right now I just want you to pause this video, right, and I want you to do the bottom one by yourself. Alright, if you didn't pause that, then that was an awkward 5 seconds. What you should have done is you should have counted how many whole slices you have. You have 1. You have 2 wholes, right? So you have 2 wholes. Your wholes are always going to be bigger than your fraction. Okay, then you count how many pieces you have available. 1, 2, 3, 4, 5 out of the 8 that make up an entire pizza, right? So if we could imagine this as a completed pizza, there'd be 8 slices. So 2 and 5 eighths. Okay, now we're going to count about how many slices we actually have available. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 slices of pizza all together at this party, at this wherever we're at our house for supper. All right, we have 21 slices available. 8 make up a whole. These numbers now show you, right, how much pizza you have entirely. If I said how many pizzas you have, either you have 3 and 4 eighths or 2 and 5 eighths, right? Or you have 28 out of 8 slices of pizza, right? So that's again how you can represent them at the same time. The next thing that we need to review and go over, let's use a green for this, right, is using fraction strips to represent equivalent fractions. All right, this is something we really struggled with in our last couple classes. Okay, so your numerator will always be how many pieces do you have, right? How many pieces do you have? Your denominator, which is your bottom number, right? How many pieces make up a whole? In the number lines that we have, this is going to be how much you divide it, right? What I mean by that is look at your denominator for this. You have 2/3. This line here, this fraction strip, is split up into 1, 2, 3 sections. All right? So for one whole, in order to get to one whole, this needs to be broken up into 3, right? And that's kind of what we talked about with number lines as well. You're going to shade in now 2 of them because we have 2. So 1, 2. Right? So this would be 2/3. Okay? You can do the exact same thing with 1 and 5/6. All right, so we want to see what that is as, well, we can see that as an improper fraction. So first of all, we can note that for the denominator, they broke this up into 1, 2, 3, 4, 5, 6. Right, so this would be 1/6, this would be 2, 6, right? If this was into a number line. We're going to shade into one hole. So one hole being from 0 to 1, right? 0 to 1 is one hole. We have all of this. All right? And 5 more 6. So 1, 2, 3, 4, 5. All right? So this bar from here to here, that will be 1 and 5, 6. It also equals then, you can in order to find if it's what is as an improper fraction, is you count out how many pieces individually have been shaded. So we have, let's use a different color so we can see that. Come on, Mr. Callum. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 over 6. All right? This number line here, it does have negatives present, but you basically can ignore that because you know that this is a positive value, right? There's no negative sign in front of it, so we know it has to be a positive value. So once again, we're splitting it into 3 slices, right? So from 0 to 1 whole, it's split into 1, 2, and this would be our third slice. 3 out of 3, right? So when we have a number line, it's important that we not only split, right, these sections, but that we also label them, right? So if I were to do this for this next one, this would be 1 whole here, and this would be 1 whole and 1 third. Okay? We're going to shade in 1 whole and 1 third. So we shade in 1 whole, 1, 2, 3, and 1 third. All right? Here we have a 2 and 3/4. Let's see if I can make this a little bit thicker. There we go. This will be a little more visually appealing. Oh, sorry. So we have to get to 2 holes, and we're splitting it into 4. So they've already done it for us, but again, it's just showing us the equivalent. All right. So 2 holes, shaded in. 1 hole. Remember, because we're going all the way to the 1, we're going all the way to the 2. All right, and then 3/4. 1, 2, 3 pieces we're shading in out of 4. So let's find what these last 2 were as improper fractions. So we're going to count. 1, 1, 2, 3, 4. So this will be 4 out of 3. It's going to be out of 3 because we still have this out of 3 pieces, right? The denominator won't change no matter if it's a mixed number or an improper fraction. All right? Let's look at the second one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right? So we have 11 out of, once again, should be 4 because these pieces are still cut in the same thing. All right? So you almost want to think of this like as your Kit Kat chocolate bars. Okay? So Kit Kat chocolate bars will always be made out of the same amount of pieces. Always 4. Right? Should have, like, I know you get the mini ones and those are out of 2. There's always an answer for against an example I give you. Okay? But Kit Kat chocolate bars, for the most part, they come in 4s. And so 4 here is going to be 4 here because it's still a Kit Kat chocolate bar. So it doesn't matter if it's improper or mixed, the denominator is going to stay the same when you're converting between the 2. So these fraction strips, right, they're used as a visual way to start converting them. The bottom number is how many pieces make up a whole, your denominator, and your top number, your numerator, is how many pieces you have. All right, converting mixed to improper. So as we can see, let me get a black for this. Okay, so as we can see, mixed to improper fractions. Using the MAD method, you're going to multiply the whole number by the denominator. So let's use this first one, 2 and 3/4. So you got your 2 and you got your 3/4. So this is our check mark method, if we remember this. So what you're going to do is you're going to multiply the whole number by the denominator. You have this 2, you multiply it by the 4. It doesn't look like a great multiplication side. Let me do that again. You got your, you have your 2, and you're multiplying it by your 4. Right? Multiply. Then, so what is that going to equal? 2 times 4, wait, make this v, right? Because you go in this direction, right? So 2 times 4 is going to equal 8. Okay? You're going to take this 8 and you're going to go up. And you're going to add the product, right? The product is the result of the two numbers multiplying, right? It's the new number, and you're going to add it to your numerator. So 8 plus 3 is going to equal to 11. Your denominator remains the same. Alright? Denominator is the same. Let's do that one more time. 2 more times. We'll do that 2. So you have 1 and 1 over 3. Okay? So remember, check mark. You're going to go down and then up. You multiply. 1 times 3 is 3. You bring it up and you add the 1. So 1 times 3 is 3 plus the numerator equals 4. The denominator stays the same. Last one. Let's get that black back. 4 and 2 over 5. 4 times 5 equals 20. Bring the 20 up. Add the 2. 22 over 5. All right? In your assignment for that you'll be working on today and that we'll go over the answers tomorrow, you'll need to know how to do this. Now, some of us might be tempted to go straight to the assignment based on how we did collectively on the last quiz. I suggest we take our time and really work through it and go back and reference this video. All right, so that was converting mixed numbers to improper fractions. Our next one is just going to be the opposite, converting improper fractions to mixed numbers. So what you have first is you have an improper fraction, 7 over 4. All right? We're going to rewrite this so that we divide the numerator by the denominator. Right? So our numerator is 7, so 7 divided by 4. Okay? You're going to see how many times is this 4 fit into the 7. So you can even count 1, 2, 3, 4. That's 1, 5, 6, 7. So it only fits ones, all right? Which is fine. 4 times 1, I'm going to bring this down. You subtract these numbers, and you're going to get 3. This is all you need to do. You don't need to find the decimal. You stop here. This in purple, right? Your whole number is going to be the quotient, all right? This is going to be your whole number. Okay? Your numerator is going to be your remainder, right? Whatever is remaining at the end, this is your numerator. And your denominator is going to stay the same, right? So either it's going to be what you divided by or the original. So that's what you should have by the end of this, all right? You divide the numerator by the denominator. The whole number in the quotient is the whole number in the mixed number. The remainder is the numerator in the fraction. Denominator stays the same. I'll do one more. You can do that other one by yourself if you wish. So let's say we have 13 over 3. So you have 13 divided by 3. All right? Let me see if I can get rid of this. Oh, that went wrong. Let's go back. 13 over 3. 13 divided by 3. Okay? 13 goes into 3 4 times. 3 times 4 is 12. Subtract these numbers. We have everything we need. Right? This is our whole. This is our numerator. This is our denominator. That's a 3. So it's going to be 4 and 1/3. So that is converting improper to mixed. All right, so next what we learned throughout this course is fraction comparison using number lines. And these are the 3 different methods, right, that we've talked about you can do. Okay? So we're just going to go through this quickly. There's more examples on the next slide, and that's when we'll go into a little more detail. If you could, it'd be excellent if you worked on these yourselves using these numbers. Right? Grab a piece of paper, work through them. All right? So drawing multiple number lines, you're going to create a number line for each fraction to compare. So you're going to, right, draw 3 separate number lines. The important thing for this is that not only are they the same length, but the whole numbers match up. Because remember, what we want to have is we want to have also whole numbers. So this is all 0 at the start. That means you have nothing. And from here, that means you have something completed. Right? That's 1 completed set, and that's 2 completed set. 2 pizzas, 2 Kit Kats, 2 chocolate bars, 2 whatever you want to think it is. All right? The denominator tells you how many times you split up whatever you have. So, right, how many pieces there are to make a whole. So there's 6 pieces. So this fraction line from 0 to 1 needs to be broken into 6 pieces. 1, 2, 3, 4, 5. And remember, this whole counts as the last and the 6th. All right? Then you're going to do the same for here. 1, 2, 3, 4, 5, 6. All right? Once you find out where 1 and 5/6 go, because you count it out, remember you should be labeling this bottom. I just don't have a lot of space. All right? At the very top, that's where you put your 1 and your 5/6. All right? Remember, you keep it in the form that it's at. Always label it. Always put where it goes on the top, and you label the bottom. All right? So this would be 1/6. This would be 2/6. 3/6, 4/6, 5/6, right? But you're looking for 1 and 5/6. We know that's 1 and 5/6 because this is 1 whole, and that is 5/6, right? Same thing for this, but instead of breaking it into 6, you're going to break it into pieces of 3, all right? So from 0, you have 1, 2, and this is our third. 2/3 would land right here, so right here is where you'd write 2/3 at the top, all right? So you have 5/6, you have 2/3, and you're going to now do 7/3. So once again, 1, 2, 3. So this would be 1/3, 2/3. This would be 3/3 technically, or 1 whole, right? And again, 1, 2, 3. Is it important that you have to be absolutely perfect to see this isn't spaced the same as this? No. What's important is that you put this relatively close in the position it should go. All right? So 7/3, you're going to count 0, 1, 2, 3, 4, 5, 6. We would need to actually add 1, and this would be 7/3 past the 2. All right? So this one, 7/3, is farther than 1 and 5/6, which is farther than 2/3 here. So 7/3 is the greatest. This is the smallest. All right, so once again, all we're doing is quickly going through that to show you that you can create a number line for each one of them, and that will help you compare the fractions. All right, the big thing is remembering that your denominator is how many pieces that gets broken up into. All right, let's go to least common denominator. For this one, right, what is important is that you turn all fractions. That means, I know we got some confusion saying, well, how can that become an improper fraction? What that rule really means is anything that's a mixed number should become improper. All right? So you have 4/6. That will become 1 times 4 is 4. That becomes 7/4, right? And you're going to have 7/3. What you then need to do is you need to write out all the multiples. All right? So the multiples are what? Oh, sorry about that, guys. Technical difficulty. So write out the denominators. Okay? So you have 6, you have 4, you have 3. you're going to write out the multiples of the denominator until you find something in common, but the least common. All right? So 6 is 6, 12, 18, 24, 30. We can stop right there. Right? 4. We have 4, 8, 12. We have our first matching pair. All right? So let's go to 3 and see if this is also can be as a 12. All right? So that's going to be 3, 6. So 6 matches with 6, but 4 does not. So that doesn't work. 9 and 12. So we have our lowest common denominator, which will be 12. 12, 12, and 12. So now it's important, in order to, you have to multiply these fractions in order to change it so that the denominator will become a 12. So we have 4 over 6. What do we have to multiply it in order for this bottom number to become a 12? Well, you count how many steps it took to get there. This is 1, this is 2, right? The second step, so you multiply that by 2. This becomes 8 over 12. All right? Same thing with this fourth. So this became 7 fourths. 1, 2, 3. So we multiply this by 3. We multiply the numerator by 3. That's 21 over 12. All right? In the last one, we have 7 over 3. All right? How many steps? 1, 2, 3, 4 steps. Okay, so we're going to multiply this bottom by 4 and this top by 4. This becomes 28 over 12. Once the denominator is the same, and I'm just going to use the space above because I'm kind of running out of space. Once the denominators are the same, you can put them all on the same number line. Okay, so once again, we're going to say this is 3. This will be 2. This will be 1, and this is 0. Those are our whole numbers. All right? Right now, you should be thinking, how can I break this down now? What should I be breaking this into? What size of pieces should I be breaking it into? Right? When I say that, I mean this from 0 to 1. What am I breaking that into? And it's always going to be your denominator. So 12. So this needs to be broken up into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Oh, get rid of that one. Ignore this. I'm going to color it black. We're going to ignore it. You're one too many. Ignore it. Okay. Do it one more time. 1, 2, 3, 4, 5, 6, 9, 10, 11. Beautiful. Now we just have to plot them. You're going to find 8 twelfths. So from the 0, you're going to count 8 spots. 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 over 12. But I didn't ask you to find 8 over 12. I asked you to find, right? Let's erase some of this other work so you can see what I'm doing. Right, I didn't ask you to find that. I asked you to find 4 over 6. So over the top, you're going to write 4 over 6. Right? 1 3/4. Right? What you would have done is you would have went through it. I think that was 21 over 12. Right? So you're going to count to 21. So this would be 12. This would be 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so here is 21 over 12, or 1 3/4. This was 28. This was 28 over 12. Right? This is 24, 25, 26, 27, 28. Noticing we're labeling the bottom and then making our placements on the top. And this is what you should have done on the quiz if you did not. All right? So we have 4, 6, 1 3/4, and 7 over 3. And we know which one is the greatest. The very last one. Right? The very last one is called benchmarks. All right? This one is by far not the easiest, but it is the one that you have to draw the less typically, but it's also where a lot of people are getting wrong because they're not actually understanding the purpose of this. So what you want is all of these fractions should be in mixed numbers. So we do our math for this is going to be 1 and 3 over 6. Right? Draw out your number line. This will be my 1 hole. This will be my 2 hole. This will be my 3 holes. Okay? Plot number based on nearest whole number or half. So what you also need to do is put where between 0 and 1 would 1/2 be. So this would be a half, right? This is approximately equal distance between 1 and 0. This would be a half, and this will be a half. Okay? So now what we need to do is we need to compare the fractions to one another and see where they would fall. What that means is not compare these fractions, but compare this fraction to where would it fall between. So 3 over 4, is that going to be greater than or less than 1 whole? Well, 1 whole would equal 4 over 4, so we know it's going to be less than, right? So it has to be somewhere, let me get out the yellow, it has to be somewhere in here, all right? Once again, you're going to do the same thing, but with 1/2 now. Okay, so you're going to say 3/4 and 1/2. If you're not too sure, you need to get these two numbers to be the same, right? Common denominator. Times by 2, times by 2, that equals 2 over 4. So which one's greater? Well, 3/4 is greater. So you know 3/4 is going to be between 1/2 and 1 whole. So you're going to put the approximate benchmark of here. Okay? Then you're going to keep doing that for all of these. Okay? 1 and 3/6, this one here, we know already has a 1 whole in it, so it has to be bigger, it has to be on this side. 1 and 3/6. 3/6 we know equals half, so 1 is going to be 1 and 3 over 6. Right? Notice again how I'm putting it at the top. 1 and 2/5, we know the 1 is going to make it this way. Let's do some erasing again. Okay, 1 and 2/5, we know 1 and 2/5 is going to be greater than 1, but 2/5, where is that going to fall? Right, 2/5, does it equal 1/2? Well, let's multiply, we have to find a common denominator. Right, that's going to equal 4 over 10 and 5 over 10. Right, so 4 over 10 is less than. So it has to be, so 1 and 2/5 should fall right here, right? Somewhere in here. So that's, again, it's a benchmark. You're comparing them between what benchmarks you set up. And the benchmarks you set up are 1 whole and 1/2. Okay, so we know that 1 and 2/5 is going to be approximately here. All right? So that's exactly what we need to do. This 5/6, right, what you would do for that is you are going to 5/6, what you're going to do for that is you're going to compare it between that 1 again. Sorry. So you have 5/6. We know 5/6 is less than 1. So now you're going to compare it to going to keep going down this chart, right? So you have 1, you have 3/4. So you're going to say 3/4 and 5/6. What is greater? Once you find it, you're going to find out that 5/6 is greater. So 5/6 is actually going to fall. 5/6 is going to fall right here, right? 5 over 6. So again, 3 different methods. This was just to review. We should be familiar with this, all right? We should know all of these methods. If you're still struggling with them, what I do have is we have more questions on the next slide, right? So right now you can pause them. What I suggest you work on then is you work on number 1, number 2, and number 5, all right? The rest aren't super realistic. This one is nice because it's already given you some of what they broke into, right? Remember, and this is the thing that I think a lot of people forget, you label the bottom. So count the pieces. 1, 2, 3, 4. So these are out of 4s. This is the first one. So this is the 1. This is the second one. That's a 2. That's 3. 1 will equal 4 out of 4. You label the bottom, and then on the top is where you would put it. Right? So 1/2 is going to be right here. Right? You put it in the form that you need to. So I suggest you practice on this. Use the stuff from before. Go back, rewatch it, use your notes. And that is kind of the explanation for just a review. A little bit longer. Most of our videos are going to be shorter, but we just covered 2 weeks with one video. Right? Take your time, move through it. What you need to do now is go to the assignment, right? The assignment that has been posted, and work through that. We're going to work through that today. I'm going to post the answers for tomorrow, right? And then we'll be moving on to ratios from there. And we will need to know this for our unit final. If you have any questions, direct message me. Good luck.